So in today's class, what we are going to see molecular orbital theory, right? What we are going to see here, molecular orbital theory. Is it fine for everyone? Just a minute. Okay, everyone. So in the last class, we have seen that. Yes, happy evening, sir. Yes, very good. Yes. So in the last class, we have seen about the, structures we have seen, VCPR theory we have seen in the last class, right? And we have drawn the so many structures, and we have seen the name of that, like either it will be a trigonal, pyramidal, or it will be a square pyramidal, like that we have seen in the last class, right, everyone? Getting my point? So who will be telling me, who will be going to tell me about the hybridization if I will be asking? If I will go to ask the hybridization, then who will be going to tell me the hybridization of any compound? If let's suppose the compound is AB2L, AB2L, then what will be the hybridization for that? What will be the hybridization for that? Who will be telling me? Anyone from you who can tell me the hybridization for that? AB2L. What do you say, guys? Forgot everything? Anil Dev, even you have also forgot? If AB2L is there, so what will be the hybridization for that? Forgot everyone. I hope nobody is answering. So what can I expect from you? You have forgot or what? AB2L is there, right? SP2. Why SP2, Anil Dev? What is the meaning of hybridization that I have told you in the last class? Everybody has forgot or what? Kaniska, what do you say? Forgot. If AB2L is there, so it means what? Yes.
I'm absent on last class, so I have to revise.
Oh, you were absent in the last class. Maurice, what do you say? Anil Dev has forgot today. Yes, Anil Dev. Maurice, what do you say? Nilambri, where were you? You were not there in the class from last two to three classes. I do remember that. Where is Nilambri? Yes. You are. Please unmute yourself first, Nilambri. Yes.
Sir, actually, as I'm having my exam actually,
I'm not able to get you.
as I'm having the exam in my school, actually, in the class.
Okay, fine. Okay, try to be regular, right? Yes, nobody will be telling me the hybridization for this. Atacha is also not there. Where is C? From biology, yes. Vuana, yes, please tell me. What will be the hybridization for this? No? Forgot. Guys, A is what? Central atom. And B, what I have told you that you have to only count what? Number of atoms attached plus lone pair. So what has been attached with this A? B2 is there. So 2 plus 1. There will be what? 3. If 3 is there, then SP2, right? Very good answer. Anil Dev has given the right answer. Forgot. Sorry, Anil Dev. You have given the right answer only, right? Okay, good. So only one person has given the answer. Only one person has given the answer. That is correct. SP2, right? I hope this trick has helped you to understand that how to get the hybridization for any molecule, right? Getting my point? And even I have asked you to learn the like the shapes as well. So how many of you have learned that shapes? Guys, try to learn all those things because that will come in your examination, right? Getting my point, everyone? So today we are going to learn about what? In today's class, we are going to learn about what? Molecular orbital theory, right? So why there is a need of molecular orbital theory? First of all, that I am going to tell you. There must be some reason to have this theory, right? Actually, BBD was failed to explain so many things, right? BBT, that is valence bond theory, valence bond theory failed to explain so many things. So that's why there is a need of what? Molecular orbital theory, right? Even it does not explain the molecular orbitals, right? Like valence bond theory does not explain the molecular orbital, and paramagnetic and diamagnetic and stability. These are the things. Yes, that is correct. To understand bonding more, see actually what VBT does not explain about the stability of the molecule, right? Stability has not been explained much. Paramagnetic nature and diamagnetic nature. Paramagnetic nature and diamagnetic nature is not much explained by VPT, right? Even the older theory is saying that O2 is what? Diamagnetic in nature. O2 is what? Diamagnetic in nature. But when you will learn this molecular orbital theory, you will get to know first time that O2 is a paramagnetic in nature. Getting my point? In general, what we are saying that even if there is an even number of electron pair is there, so that will be diamagnetic in nature. Yes. If even number will be there, then that will be called as what? Diamagnetic. O2 is at what number? 8 number. It is coming at what? 8 number. If it is coming at 8 number, it is what? Even number. And if even number is there, then it is a diamagnetic in nature. But molecular orbital theory is saying that O2 is not a diamagnetic nature. O2 is not in diamagnetic nature. It is a paramagnetic nature. Getting my point, everyone? Is it fine for everyone? Is there any problem? Pradyuman Dubey, guys, please welcome Pradyuman Dubey. He has joined today after almost more than 1.5 months. Pradyuman Dubey. So once he is joining, I hope I request you to give a big hands for him, right? Because he has joined after so many days. So those who will be joining like after 1 or 2 weeks, right? Then for them I will be making a clapping will be there for them, right? So guys, be regular in class. It's my humble request to you. You have invested so many lot many things for here. You have invested more money for here. So why are you not joining? It's a waste of money, right? Okay. So yes, guys. So why there is a need of molecular orbital theory that we have seen here, right? Now, so you will be seeing like this structure will be there, right? But this I will be explaining later part of the class. That is what there will be bonding also, and there will be anti-bonding will be there, right? So who will be going to tell me bonding and anti-bonding? I have one question right now. and I will explain these things in the later part of the class. Bonding means what? There will be more energy or less energy. Who will be telling me? Bonding part will be having the more energy or less energy. Nobody will be saying me. Oh my God, here it has been written although. Antibonding orbital higher energy than the atomic, than that of orbitals. Bonding orbitals lower energy than that of atomic orbitals. See guys, bonding means what? Earlier we have known the atomic orbitals. I hope everybody is knowing about the atomic orbitals. Now we will be seeing about the molecular orbitals. Getting my point, everyone? We have seen about the atomic orbital, yes, but we haven't discussed about the molecular orbital. Molecular orbital means what? If oxygen and oxygen, that both will be combining, so it will form what? Molecular orbitals, right? If fluorine and fluorine is there, both will be combining, so there will be a molecular orbital will be formed. Molecular bonding will be formed. But if I will be asking about the oxygen, so it's a single atom. So we are discussing about what it is. We are discussing about the atomic orbitals. What is this orbitals? What is the orbital? Do you know, guys, what is this orbital? The maximum chance or maximum probability of finding the electrons. If you will be asking there, sir, what is your orbital? So my orbital will be what? Either in Mumbai, because this TG campus is based out of where? Mumbai, or either my hometown. So these will be the orbitals for me, either Mumbai or either my hometown. What do you say? If I will be asking your orbital, then your orbital will be what? Either your school or either your home, where there will be maximum chances that there will be you. What do you say? So the orbital is what? That the maximum chances of finding the electrons. Getting my point? So where there will be a probability of electrons will be there, that will be the orbitals of the atom. So atomic orbitals. Now we will be looking out about the molecular orbitals. Getting my point, everyone? Is it easy now? Okay, now. So this was the reflection of the class, right? Now we'll be going to see about more things. See, we have seen that the sp orbitals will be how they will be looking like. sp2 orbitals, trigonal, planar, linear, that we have seen the last class. sp3 orbitals that we have seen. Sp will be of linear, right? We have seen in the last class. Sp will be what? Linear. sp2 will be what? Trigonal, planar. sp3 will be what? Tetrahedral. That is what? The sp3 is what? 4 orbitals has been combined to form this sp3 orbitals, right? Examples are what? GeCl4, SO3, CO2. These are the examples of 2, 3, and 4. That is sp, sp2, sp3 orbitals. Getting my point, everyone? Is there any doubt? Okay. Now, come to the next point. So I hope this also you are knowing, that is dsp3. So dsp3 means what? It is a type of what? AB2, AB4L or AB5? Who will be telling me? If dsp3 is there, Anil Dev, if dsp3 is there, so the molecule will be what type? It will be dsp3 if it is dsp3. So can we say AB5 type or AB4L? AB4L, can it be like this, AB4L or AB5? Those who were there in the last class, I hope they are understanding now. Maurice, what do you say? AB4L or AB5? Sorry, sir, I forgot, sir. What do you say, Maurice? Do you remember or not? First tell me that. It will be AB4 if I am saying that the okay. So Asrita, have you brushed today? Have you done close up today? Brush your teeth. So guys, got my point? Maurice forgot or what? Asrita, yes, please go ahead. Yes, tell me. Yes, Asrita. So guys, we have seen
Yes,
what?
sir.
dsp3 will be there.
Yes.
So in case of what? If there will be either AB5 type, if
Sir, I
it
was
will be what? AB5 type, or it can be what? AB4L. If it will be a type of AB4L or it will be a type of AB5, then there will be the hybridization will be what? dsp3, yes or no? See 1 as P3, that is what? 1 plus 3, 4, and there is what? D. So total number of orbitals that are involved in this will be what? 5. So we can say that the hybridization for this will be what? The hybridization for this will be what? DsP3. So the common example is what? PCl5. Getting my point, everyone? Okay, no problem, SB Amrinthe. How are you all? I request to each and everyone, please turn on your camera. So, SB, you were there in the last class? Yes? So, if I will be going to ask you about that, if let's suppose, if I am saying that there is a molecule of type AB4L2, AB4L2, so what will be the hybridization for that? AB4L2. Do fast. AB4L2. Otherwise, Anil Dev will give the answer for this question. If you will not give, then Anil Dev will give the answer for this. So I will not be giving you much time because Anil Dev is ready to give the answer. Yes?
Shape. It will have CLF3 shape.
CLF3 shape. Can you send me the hybridization for this first? Then I will be looking for the shape.
Yes, sir.
Yes. No?
Sir, I'm not getting it.
Okay, no problem. Anil Dev will tell me. Anil Dev, please turn on your mic and then say me. What do you say? What I have asked you? D2sp3.
I mean, AB4L2.
Yes, AB4L2. Yes.
SP,
So yes.
SP3D2, sir.
AB4L2 here, right? So how many if I will be counting, then 4 plus 2, right? This will be what? 6. So sp3. So here till here what we have got? 4. So D2. Yes, right answer. sp3D2. Getting my point, everyone? How many of you have got all these things that I have discussed till now? Or you have forgot everything? Or you have confused? Or you have getting more confusion, sir, what you are telling today? Because guys, we have discussed same things in the last class. The last class is all about all these things only, right? VCPR theory, we have discussed about the VCPR theory. We have seen about all these things. We have even discussed about the hybridization. But you have forgot. Why you are doing so, I don't know. But guys, please be conscious in the class. Whatever will be the things that are discussed in the class, try to revise that after the class only. Because this 2 hours of lecture is, if you will be not revising just after your class, then it will be washed away. And that will be not of use. Okay, now see here. So we are discussing about this. So if there, yes, you can see here 5, then 6, D2, sp3 that we have discussed, right? Now, so just a minute. Just give me 1 second, guys. Yes, guys. So what we are going to discuss about, that is what? Molecular orbital theory, right? So we have discussed about the VPT. Now we are going to discuss about the molecular orbital theory, right? So see, molecular orbital theory was developed by F. Hund, that we have seen in the atomic structure about the Hund's rule. Who will be telling me about the Hund's rule? Anybody who is learning, who have some idea about the Hund's rule or Hund's rule? Somebody is saying Hund's, somebody is saying Hund's. So what do you say about the Hund's rule? Who will be telling about the Hund's rule? Do you remember, guys? Anyone? I have made you learn about 3 rules. That is Above principle, Paul's exclusion
Sir,
principle.
can you hear me?
Yes, I can hear you about the Hund's rule.
Sir, the Hund's rule is about the maximum multiplicity.
Yes,
It is used to predict the ground state of an atom
yes.
with their open electronic shells.
So what do you say? Like if an orbital can have maximum 2 electrons, 3 electrons, 4 electrons, 5 electrons, what is the
Yes,
correct answer according to
sir,
Hund's?
it should be 1, 2, 3.
1, 2, 3. How you are saying 1, 2, 3? Maximum number of electrons that can be filled, that will be 2 only, right? So
Yes, the
Buana
2
is
you have
giving you
said.
the see, Buana is hinting you from his finger only, right? Getting my point?
Yes, sir.
So it is a multiplicity rule, right? You can say the multiplicity rule of the Hund's, right? So the maximum number of electrons that will be in one orbital will be 2, but that will be in opposite. Yes, that will be in opposite spin. So there were three rules were there. One was what? The Hund's rule, a Bose principle, and Pauli's exclusion principle was there. So how
Yes,
many of you
sir.
are knowing about all these three rules? One rule was that the lower energy orbitals will be filled first, like lower energy orbitals will be filled first, then we will be moving into the higher energy level, right? Do you remember, guys? Yes or no? Like until unless if we are not filling the s orbital, we cannot directly jump into the p or d orbital, right? Do you remember or not? Forgot everyone. Guys, try to get revision of all these things that we have discussed in the past, right? Because in chemistry they are coming, like not only in chemistry, in every subject they are coming again and again, right? So the molecular orbital theory was developed by Hunt and R.S. Mulliken in 1932. The basic idea of molecular orbital theory is that atomic orbitals of the individual atoms combine to form a molecular orbital, right? Let's suppose hydrogen is there and another hydrogen is there. So their orbitals will be combining to form the molecular orbital, right? So H and H will be combining. So it will be from what? H2 or not? Now atom, it's now what? Molecule, because H, one atom of hydrogen has combined with the another atom of hydrogen to form a molecule. So we will be learning about the molecular orbital of this hydrogen now. Getting my point, everyone? So the electrons in the molecules are present in the molecular orbitals which are associated with the several nuclei, right? So what are the several nuclei? Let's suppose if I am talking about the oxygen. So oxygen will be having what? One nuclei. But if oxygen has combined with another oxygen, so both the oxygen has been combined, so there will be a nuclei will be what? The number of nuclei will be what? What do you say? The number of nuclei will be 2. Getting my point? Getting my point, everyone? Yes or no? Easy for you? Understand? So see that has been given here. Electrons will be filled in the orbital with order of energy, increasing energy. Good. Okay. So that which are associated with the several nuclei, the molecular orbitals are filled in the same way as the atomic orbitals in atoms are filled, right? So how the atoms are filled? In atomic orbitals, in the same way, the molecules will be also filled. The molecular orbital will be also filled, right? The molecules will fill in the molecular orbitals in the same way. Getting my point, everyone? So what has happened in the atomic orbitals? There was less energy, and less energy orbitals are filled first, then the higher energy orbitals, right? Getting my point, everyone? Let's suppose if I will be asking you the electronic configuration of, let's suppose what? Cr. One question is this, and another question is what? Manganese. Who will be giving me the answer of this question? Electronic configuration of Cr and manganese, Mn. Guys, can you give me the answer for this question? Try to give me the answer for this question. Then I will be explaining you more about this. How we can distinguish this. That first the lower energy orbitals will be filled, then the higher energy orbitals will be filled. What will be the electronic configuration of Cr and Cu? Not Cu. Manganese I have given you guys. Mn. Cr and Mn. Cr and Mn. Do fast. How many of you have found the question? Guys, don't take the help from Google Baba. Try to do by yourself only. If you are knowing, then fine. If you are not knowing, then also it will be fine for me. I will be explaining you once again. Otherwise, if you are taking help from Google Baba, then that will be not going to help you right now. Even in the future also, only taking the help from the Google will not be helping you more. One S2, 2S2, 2P6, 3S2, 3P6, 4S1, 3D5 for CR is not sure. Is not sure. Okay. I not sure. Okay. You are sure? The right answer is this only for CR. Got my point, Anil Dev? So this is the right answer. So 1S2, 2S2, 2P6, 3S2, 3P6, 4S1 and 3D5. So the right answer should be what? 4S1 here. What do you say? Guys, those who are understanding, then please tell me. So what should be the right configuration for CR? 4S2, 3D4, right? The last electron should enter into what? The last electron should enter into what? S. Actually, what happens? First D are filled, then S are filled, right? Getting my point, everyone? When the electrons are removed, first S electrons are removed, then the D electrons are removed. Getting my point, everyone? So 4S1 3D4 is there, right? It means why you have written this answer 3D4 and 4S1. Sorry, 3D5, 4S1. Because I have told you in the class that
Sir, in order to make all the orbitals filled up, either to make it stable, in order to make it stable,
if you are saying, see, for your first point, this is wrong, because if you will be seeing that first or all orbitals, then almost every orbital is filled there, right? But
Yes,
if you are saying yes, for getting the stability purposes, then it is correct, right? Because 4S1, 4S1 and 3D5, so here there is a half-filled configuration will be there.
Yes.
So wherever there will be a half-filled configuration will be there.
There will be stability.
So there will be more stability. Not only stability, there will be more extra stability will be there. Getting my point?
Yes, sir.
Easy. So in the similar way, see, you can see here that the electrons in the nucleus are present in the molecular orbitals which are associated with the several nuclei, right? The molecular orbitals are filled in the same way as the atomic orbitals in the atoms are filled. So we will be learning about how the atoms are filled in the atomic orbitals and how the molecules will be filled in the molecular orbitals. Getting my point? So those who have given this answer, that is correct. For manganese, if I will be asking, then what will be the right answer? 4S2, 3D5, right guys, everyone? 4S2, 3D5, because manganese is coming just after chromium, then manganese, right? Just after this. So atomic number is what? 25. Atomic number of manganese is what? Atomic number of manganese is what? 25 only, right? What do you say? So 4S is what? 4S2 is what? Calcium, that is 20, right? Then after scandium, titanium, vanadium and chromium, and then manganese is coming. Scandium is 21, vanadium is 22, scandium, titanium, Ti, then vanadium 23, then chromium, that is 24, then manganese, that is 25. So if 25 is there, so 3D5 will be there, right? And there is no any exceptions with this manganese, right? Exception lies with Cr and Cu in the 3D series. Are you able to understand me, guys? Anil Dev, getting my point? The exception lies with what? Cr and Cu, 24 and 29. The atomic number 29 will be having the electronic configuration of what? 4s1 3d10, right? Although it should be 4s2 3d9, right? But there is exception case is there, so the electronic configuration is what? 4s1 3d10 is there, right? So now we are going to learn about this molecular orbital theory. Sir, you may ask me, sir, as we are knowing the atomic orbital, We are knowing the valence bond theory. So why there is a need of this molecular orbital, right? So write first 2 to 3 points. See what does this molecular orbital gives us? What does this molecular orbital gives us? Do you know, guys? Actually, it is giving what? BBDSP. Is there anyone in your contact who is DSP? Do you know what is the full form of DSP? Anyone who is knowing about the DSP, full form of DSP? Anyone who is knowing DSP? What is the meaning of DSP? Anyone? SB is laughing. SB, you are knowing the full form of DSP? Lady Singham, you might have seen Singham and all, right? So DSP means what? Deputy Superintendent of Police, right? So BBDSP. So in Hindi, BB is what, you know, wife. So BBDSP, right? So BBDSP, what we are going to learn? We are going to learn BBDSP, so through molecular orbital theory. So what is this BB? What do you say? What is the meaning of this BB? Bond order, bond length, right? First B is what? Bond length. Another B is what? Bond order. And BB. D means what? BBDSP. D is what? That is diamagnetic in nature. S means what? Stability. And P means what? Paramagnetic nature. So if anybody will be asking you, why there is a need of molecular orbital theory? To understand BBDSP. So that is what? B means what? That is bond order. And what is there? Bond length, then stability, then diamagnetic nature and paramagnetic nature. Getting my point? Is it easy now, guys? Is it easy now? So what we are going to learn about in this molecular orbital theory? So BBDSP, right? Now see here. So guys, so understood that what we have to learn here. Now see here. In molecular orbital theory, there are 6 to 7 postulates are there, right? So we will be learning these postulates. Try to learn here, right? Because after this, we will be doing so many things. So first learn this molecular orbital theory, the postulates of molecular orbital theory, right? Wherever you will be not understanding, then please tell me. I will explain once again that part, right? Getting my point, everyone? So see here. Just like an atom, molecule has orbitals of definite energy levels, right? Just like an atom, molecules has orbitals of definite energy levels, like electrons of atoms are present. Electrons of molecule are present in different molecular orbitals. Getting my point? So let's suppose if I am talking that hydrogen is hydrogen atom is will be here in s orbitals. So molecular orbitals like what? H and H will be combining. So that will be also having one orbital, right? That will be called as what? Molecular orbital. Getting my point, everyone? So this is the first point. Second point is what? Molecular orbitals are formed by the combination of atomic orbital of proper symmetry and comparable energies. Getting my point, everyone? So molecular orbitals will be formed by what? So by comparable energies. Getting my point? What do you say? Molecular orbitals are formed by combination of atomic orbitals of proper symmetry and comparable energies. So 1s will not be formed with 2s. Because why? Because there is an energy gap between 1s and 2s. Like same orbitals will be combining with each other. Because why? Because they are having the same energy level. So 1s will not be going to combine with 2s. Getting my point? Like as you can see in the middle class family will marriage with middle class family only. The middle class family will be not going to marriage with higher class, or you can say that the executive class. Getting my point? So 1s will marry with what? 2s, not 2s, sorry, 1s only. Getting my point? So they will be forming what? Molecular orbital. Getting my point? Because why they will be not combining with 2s? Because 2s will be having the higher energy level. So higher energy level will not be matched with 1s level. So there will be the combination between 1s and 1s only. Getting my point? Is it fine for everyone? So this postulate is clear for each and every one. Molecular orbitals are formed by the combination of atomic orbitals. Available energies, the atomic orbitals of these atoms merge into the molecular orbitals. So now this is the second point. And the third point is what? An electron in atomic orbital is under the influence of one nucleus. See guys, this is third postulates of molecular orbital theory is what? In atoms, oxygen is having how many nucleus? If I'm asking about oxygen atom is there, so it will be having what nucleus? See guys, how the electrons are arranged in atomic orbital. See, this is the nucleus. So this is 2 electrons, and in the second cell, so 2, 3, 4, 5, and 6 electrons are there, right? This is for what? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. What do you say? Hydrogen, helium, then lithium, beryllium, boron, carbon, nitrogen, oxygen. So how these are arranged? How these are arranged? So one nucleus is there, right? One nucleus is there for atomic orbitals, right? Yes, so many people have written Deputy Superintendent of Police. Yes. So what is there? One nucleus is there, right? But in molecular orbital theory, there will be 2 electrons, 2 nucleus can be there, not less than 2. Getting my point, everyone? Easy now. So this is what the third postulate that we are learning here. An electron in atomic orbital is under the influence of only one nucleus. However, an electron in a molecular orbital is under the influence of 2 or more nuclei, depending upon the number of atoms present in the molecule. Getting my point, everyone? Now, fourth point is what? Just as the electron probability distribution around the nucleus in an atom is given by atomic orbital, the electron probability of distribution around the group of nuclei in a molecule is given by molecular orbital. What do you understand by this? As I have told you that probability of finding me will be what? Either in TG campus, Mumbai, or either at my residence where I am residing, right? So in the similar way, the electrons of the atoms will be finding where? In the orbitals, atomic orbitals, right? But the number of molecules or the number of electrons of molecule will be finding where? In the molecular orbitals. So that has been given here is what? Just as the electron probability distribution around the nucleus in an atom, right? So the probability of finding the electrons in the atom will be where? Near the nucleus, right? But in the molecular orbital theory, they will be in the where? They will be in the molecular orbital. The electrons will be the probability of finding the electrons in the molecular orbital. Getting my point, everyone? No. Fifth postulate is what? The number of molecular orbitals formed is equal to the number of combining atomic orbitals. The number of molecular orbitals formed is equal to the number of combining atomic orbitals. Means what? What will be the molecular orbitals? Let's suppose 1s is combining with 1s. So they will be combining together. Getting my point, everyone? So what has been given? The number of molecular orbitals formed is equal to the number of combining atomic orbitals. So how many atomic orbitals are combined? So on that basis, we can be saying about the molecular orbitals. When 2 atomic orbitals combine, they form 2 molecular orbitals. It will be not forming 4 atomic orbitals. Getting my point? If 1s is combining with 1s, it means what? If 1s is combining with 1s, it is forming what? It is forming what? Like 2 atoms are combining, right? So it will be forming 2 only. 2 molecular orbitals. It means what? Whatever be that you are giving, that much only you will be getting. If you are giving me 10 rupees, so in return you will be getting only 10 only. It doesn't mean that if you are giving me 10, so you will be in return you will be getting 20. This is not going to happen here, right? So if 1s and 1s is combining, so you will be getting what? you will be getting what? 2s and 2s. Getting my point, everyone? So two orbitals will be formed. Now, so the number of molecular orbitals formed is equal to the number of combining atomic orbitals. When two atomic orbitals combine, they form two molecular orbitals. So these are called bonding molecular orbitals and anti-bonding molecular orbitals, right? So what are these? These are bonding molecular orbitals and anti-bonding molecular orbitals. So now you may be asking me that, sir, what is this bonding orbitals and what is this anti-bonding molecular orbitals? First of all, just know only one thing. This is very important for you to understand that what is like bonding orbital, right? And what will be the energy? Like bonding molecular orbital will be higher energy, or the anti-bonding molecular orbital will be having the higher energy. I have asked this question in the beginning of the class. So you might have not got the answer till yet, right? So my answer is what? Anti-molecular orbital will be having higher energy than bonding molecular orbital. You may have a note of this, that bonding molecular orbital will be having lesser energy than anti-molecular orbital. Getting my point, everyone? Why this happens? Once the bond is formed, there will be having less energy. They will be having lesser in energy. Getting my point, everyone? Okay, now fine. Now, the bonding molecular orbital has lower energy, right? And hence greater stability. One more thing is that those who are having bonding in nature, they will be having higher in stability and lower in energy. What do you say? What do you say? Those who are having higher energy, they will be having lesser stability. And what do you say? Those who are having lower energy, they will be having higher stability. So bonding molecular orbital, BO. Getting my point, guys? Bonding molecular orbital, BO. It will be having what? Lesser, higher stability, then they will be having what? Lesser energy. Energy will be lesser. In antibonding, AB, ABO, so they will be having higher energy, lesser stability, they will be having lesser stability, right? So the bonding molecular orbital has lower energy and hence greater stability, whereas in corresponding with the antibonding has more energy and hence lesser stability. So what do you understand by all these points, guys? Do you understand that bonding will be having higher energy and lesser stability? Antibonding will be having lesser energy and higher stability. Sorry, more energy and lesser stability in antibonding case. Easy? Now, see here. The seventh point is what? The molecular orbitals are filled in same as atomic orbitals are filled in accordance with above principle, Pauli exclusion principle, and Hund's rule. I hope you might be knowing about all these three rules. That is what? Hund's rule, Pauli's exclusion principle, and above rules. Do you remember, guys? Although we have discussed in the first that what is this Hund's, what is this above principle, and Pauli's exclusion principle. So first, lower energy orbitals will be filled, then the higher energy orbitals will be filled. The second is what? That they will be filled in what? Like opposite spin will be there, right? Like one will be filled after another, and there will be the direction will be what? One will be in what? Plus, you can say that there will be what? It will be filled like this. And one more thing is that what was there? Like until and unless this, if I'm talking about the p orbitals, right? So until and unless this 3 will be not filled, so this will be not filled. Getting my point? It doesn't mean that first we will be filling this whole first orbital, that is px, then we will be moving out ahead py and pz. Easy for everyone. What do you say, guys? Easy till now? So now, next. Molecular orbitals are formed by the combination of atomic orbitals, bonded atoms, right? We have learned according to wave mechanics that atomic orbitals can be expressed by wave function, that is psi 8, right? The wave function represents the amplitude of the electron waves. These are obtained from the solutions of Schrödinger wave equation, right? Guys, we will be learning also about the constructive and destructive wave. Constructive and destructive interference. You might have learned, or you will be going to learn in your last part of your 11th. That is what constructive and destructive interference. Getting my point? So there will be a question in your in this probably in your class assessment that what refers to bonding, destructive interference or constructive interference. There will be one question will be there. So see guys, you have to also understood that constructive interference leads to the bonding orbital, BO, and destructive interference leads to the formation of anti-bonding orbital. Getting my point? Okay, fine. Now, to overcome, as we have discussed, that I have told you these all things, right? To overcome this problem, scientists have used an approximate method that known as linear combination of atomic orbitals, abbreviated as LCO method, right? Formation of molecular orbital, that we will be seeing right now. See guys, there will be not much use of this, right? That we will be seeing later part. These two combinations give rise to molecular orbitals as described below. That is what molecular orbital obtained by addition of wave functions of atoms, right? And there will be a subtraction as well, right? So the molecular orbital obtained by subtraction of wave functions. So you have to just remember only what there will be addition of wave function, and there will be what there will be a subtraction of wave function. Getting my point, everyone? If there will be a subtraction, so there will be anti-bonding molecular orbital will be there. If there will be addition, so there will be what? There will be what? Bonding molecular orbital. Clear with everyone? Is there any problem till now? So molecular orbital obtained by addition wave functions of atoms, that will be represented by what? That is psi, or psi A plus psi B. Getting my point? Now, see, what does this sigma star tell us? That we will be discussing just after this, right? And sigma, yes. Now, see guys, how will be the overlapping of the orbital that I was discussing, right? So 1s will be combining with 1s only. So 1s will not combine with 2s, because 2s will be having the higher energy than 1s. So there will be overlapping will be not possible. So if 1s is combining with 1s, so there will be a formation of what? There will be a formation of what? Formation of bonding molecular orbital will be there, and that bonding molecular orbital will be what? Sigma 1s. Sigma 1s. Getting my point, everyone? So you may ask me, sir, how the sigma 1s? See here. Then another 1s and 1s will be combining, right? There will be a formation of anti-bonding molecular orbital, that is anti-bonding molecular orbital, that is what? Sigma star 1s. See guys, if there will be this type of combination will be there, right? If there will be this type of combination will be there, so there will be a sigma bond will be formed. But if there will be axial, or you can say if there will be overlapping like this, so there will be a pi bond will be formed. There will be a formation of pi bond. Getting my point, everyone? So here there is a formation of what? Sigma bond is formed. Sigma bond is formed by the overlap of 1s and 1s, right? So 1s overlapped has shown you what? There will be a 1 that you can say sigma 1s, right? Sigma 1s. Is it fine for everyone? So one will be what? That is one formation of bonding orbital. Another will be combination will be what? The anti-bonding molecular orbital. That will be giving you what? Sigma star. That we are saying what? Sigma star. We are writing what? Sigma star 1s. Sigma star 1s and sigma 1s. This is what? This is bonding molecular orbital, and sigma star 1s will be giving you what? Anti-molecular orbitals. Getting my point, everyone? Sigma star 1s will be giving you what? Sigma star 1s will be giving you what? Anti-molecular orbital. Guys, write in the chat section. I want your answer in the chat section. Everybody please write in the chat section that sigma star 1s will be giving you what? Bonding orbital, bonding molecular orbital or anti-bonding molecular orbital? Sigma star 1s will be giving you what? Bonding molecular orbital or anti-bonding molecular orbital? So only one people has written, that is anti-bonding molecular orbital. DRC has also written anti-bonding molecular orbitals. Morris has written anti-bonding molecular orbitals. Yes. So guys, everyone, please write in the chat section. I want the answer from you. Right answer is what? Anti-molecular bonding orbitals. Yes, very good answer is coming from you guys. Very, very good. Now, see guys, so what is the difference between the atomic orbitals and molecular orbitals? An electron in atomic orbital is under the influence of only one positive nucleus of the atom. Molecular orbitals, an electron in molecular orbitals is under the influence of two or more nuclei depending upon the number of atoms present in the molecule. Getting my point, everyone? Is it fine for everyone? Next, in atomic orbital, atomic orbitals are inherent property of an atom. In molecular orbitals are formed by the combination of atomic orbitals. So 1s and 1s will combine, 1s and 1s will be combining. So what will be formed? 1 sigma s or 1 sigma star s. Sigma star 1s, you can say. They have simple shape. They have complex shapes. You getting my point, everyone? Easy. So do you want break? So have a break of 5 to 7 minutes, then we will be back, right? Okay, fine. Are you there, everyone? Okay, Ratachaya, no problem. Power cut here, sir. Okay. Everyone is there. Please turn on your camera. Atachaya, where were you? Light cut. Thank you so much for your gift that you have given on the day of Teachers' Day. So all teachers were like, seeing that what you have made, that was really good. And thank you so much. Thank you so much to the class that you have given your so many comments for that. Thank you so much for that. And now come to the next point. So Atacha, you have made by yourself only, or you have taken help from somewhere else? So okay, that was really very good. Okay guys, now come to the next point. So we are going to see about what? See, so atomic orbital and molecular orbital that we have seen, right? Now, although this is, somewhat you can say extra point is there, but we have to discuss. So we have seen what that I have told you to make you understand only. So destructive interference and the constructive interference that we will be going to see here, right? So one will be what? See here, two waves in phase and two waves out of phase. Two waves in phase and two waves out of phase. So sigma A plus, that is what? Psi A plus B, and that in destructive interference it will be what? Psi A minus Psi B. Getting my point? Psi A plus Psi B. Here Psi A minus Psi B will be there. So this is a small part only. What will be the question that will be coming in your examination? That is from here only. During constructive interference, the two waves are in phase and the amplitude of the wave get added up, right? Therefore, resulting wave function has more electron density in between the nuclei. This corresponds to bonding molecular orbital. I have asked you in the very first, right? Do you remember, Anil Dev? Do you remember? Got the answer that molecular orbital and anti-molecular orbital, right? Or constructive interference will corresponds to the molecular orbital or bonding molecular orbital, right or not? I have told you these things in the first beginning of the class, that constructive interference will leads or corresponds to the what? Bonding molecular orbital, and destructive interference will leads, or you can say that will be corresponds to the anti-molecular orbital, right? Destructive anti-molecular, constructive bonding molecular. Getting my point, everyone? Is it fine for you? Any problem till here? Constructive, who will be telling me? Constructive will be what? Bonding molecular orbital, or write in the chat section. Bonding molecular orbital for constructive and anti-molecular orbital for destructive. Write in the chat section, guys. I request you to write in the chat section. Yes, Atajaya, myself. Thank you, sir. Okay, very good. Welcome. Now, on the other hand, when the two waves are out of phase, there is destructive interference and the amplitude of the waves get subtracted or cancelled. Therefore, the resulting wave function has less electron density between the nuclei. This also gives rise nodal plane between the two nuclei. This corresponds to the wave function of anti-bonding molecular orbital. This corresponds to the wave function of anti-bonding molecular orbital. So, constructive bonding molecular orbital, destructive anti-bonding molecular orbital, CMO, Chief Minister of India, CMO office, right? DAMO, District Additional Magistrate of India. CMO, DAMO. You have to learn. Constructive, C, bonding molecular orbital. C, it will be giving what? Bonding molecular orbital. And D, destructive, it will be giving what? AMO, anti-bonding molecular orbital. Easy? So this question will be coming in your class assessment as well. So there you have to give the right answer, right? So there is no need to write this now, right? Or you can even say you are a mathematician student. You are from the mathematics background. So psi square equals to what? Psi A plus psi B whole square. So it will be what? Psi A square plus psi B square plus 2 psi A psi B. Getting my point? So there is no need of no use of this much, right? Now, relative energies of bonding and anti-bonding molecular orbital. Although I have told you that bonding molecular orbital will be having lesser energy. Bonding molecular orbital will be having lesser energy, and anti-bonding molecular orbital will be having higher energy. Yes or no, guys? I have told you or not? First tell me that. So we have learned in the case of bonding molecular orbital, the attraction of both the nuclei for the both electrons is increased, right? So this results in the lowering of energy, right? In the case of anti-molecular orbitals, the electrons try to away from the nuclei, and this corresponds to the repulsive state, right? So the energy of this orbital will be higher. The relative energy of bonding and anti-bonding molecular orbitals along the atomic orbitals are represented. That we will be seeing here, right? See, this is a what? This is at lower end, right? This is as what? This is at lower end, and this is called as, so this diagram, this molecular orbital diagram will be showing you what? You have to not, don't have to write anything. 1s and 1s, right? This is what? 1s and 1s. Getting my point? This is what? Atomic orbital, 1s and 1s. They will be combining to form what? See here. One will be sigma 1s. As why we are writing sigma 1s? As they are what? They are combination of what? S and S orbital, right? So SS orbital will be giving you only, sigma bonding, not pi bonding. So if there will be sigma bonding will be there, so you can see here, one sigma S and one sigma star S. Getting my point? So this will be molecular orbital, this will be anti-molecular orbital, AMO, anti-molecular orbital. Getting my point? And this will be called as what? This will be at lower energy level. This will be at what? Lower energy level. Lower energy level. Lower energy level. Getting my point? Sorry. Yes, lower energy level. So it is what? More stable. If it is stable, so it will be having lower energy level. It is not much stable, so it will be having higher, more energy level. More energy level. Getting my point, everyone? Is it easy now? Any problem till here? If there is any problem, then please tell me. Is there any problem? Okay, no. Thus the bonding molecular orbital is stabilized related to the energy of isolated atoms, and anti-molecular orbitals is destabilized related to the anti-individual atoms. Further, it may be noted that the bonding molecular is stabilized to the same extent as the anti-bonding molecular orbital is destabilized. So guys, bonding will be stabilized, and anti-bonding will be what? Destabilized. Bonding orbitals will be having lesser energy, and anti-bonding orbitals will be having higher energy level. Getting my point? Who have not got this? Can you please tell me? Bonding will be having higher energy level or less energy level? Bonding orbital will be having higher energy or less energy? Write in the chat section. Bonding orbital will be having higher energy level or less energy level? Write in the chat section, everyone. I want your answer in the chat section. Please write. Lesser. Very good. Anti-bonding will be having higher energy level or lesser energy level? Anti-bonding orbitals will be having higher energy level. Very good answer that you are giving. Antibonding higher and bonding lesser. Very good answer. No. So you can see here bonding orbital and anti-bonding orbitals, right? What is the difference between this? Bonding molecular orbital is formed by the addition of overlapping of atomic orbitals, right? The wave function of the bonding orbitals may be written as bonding orbitals wave function will be written like what? Bonding orbitals, right? Psi A plus psi B. It will be equals to what? Psi A plus psi B. And in case of, see here, anti-bonding molecular orbitals formed by the subtraction of overlapping of atomic orbitals, the wave function for the anti-bonding will be what? You can see here, psi star. It will be written as psi star. And it will be psi A minus psi B. Getting my point, everyone? They are formed when the lobes of the combining atomic orbitals have same sign. They are formed when the lobes of the combining atomic orbitals have opposite sign. Now, you can see here, it has greater electron density. It has greater electron density in the region between the two nuclei of the bonded atoms. It has lesser electron density region between the nuclei of the atoms. Fourth point is what? The force in these orbitals tend to bring the two nuclei of the atoms together. The forces in the orbitals tend to bring the two nuclei of the atoms together. Therefore, electron in the bonding orbital contribute attraction between the two atoms, right? So there will be attraction between the two atoms. Here the force this orbital push the nuclei apart. Therefore, electron in anti-bonding orbital contribute to the repulsion between the atoms. So there will be repulsion. Here there will be what? Attraction will be there. It possesses lower energy than the isolated atomic orbitals that we have seen. It possesses higher energy than the isolated atomic orbitals. Now guys, there we have to see that how the atomic orbitals are combined. So 2pz will be combining with 2pz only. It will be not combining with 1s. So if it will be combining, so what we will be getting here, you can see here, sigma 2pz. Sigma 2pz. Getting my point? Another 2pz and 2pz will be combining to give sigma star 2pz. Here there is a mistake, guys. Sigma star 2pz will be there. So wherever there will be not sigma will be there, it will be bonding. If there is sigma is there, it is anti-bonding. It is representation, guys. Bonding will be represented by sigma 2pz and anti-bonding will be represented by sigma 2pz. Molecular orbitals from the 2pz atomic orbitals. Getting my point, everyone? Now, you can see here what is happening here. 2px, 2 both are combined, right? So what we are getting, see, this is a type of, see, I have told you that if there is overlapping of this kind, see guys, if there is overlapping of this kind, overlapping will be there. So sigma bond will be formed. But if the overlapping will be sideways, see here, if the overlapping will be like this, so pi bond will be formed. If the overlapping will be like this, if the overlapping will be like this, just a minute. If the overlapping will be like this, so it will be what? It will be what? It is formation of sigma bond. But if the overlapping will be like this, so it will be what? 6. We are doing what? When there will be a 6 in the match, cricket match, so we are doing what? We are taking our hands to in the sky, right? So it will be a formation of pi bond. Getting my point? This is a formation of pi bond, and this is a formation of what? Sigma bond. And sigma bond is more stronger than pi bond. Is it clear, everyone? Is there any problem? Okay, very good. So you can see here, there is a formation of what? Sigma bond, right? But here there is a formation of what? There is a formation of pi bond. So pi 2px. You can see here 2px and 2px combining another 2px has been combined to form pi star 2px. Here there will be what? Pi 2px. Pi 2px. Here there will be what? Pi star 2px. Getting my point? No. So what is the difference between sigma molecular orbital and pi molecular orbital? So there might be some differences between this. So that we will be going to discuss here. It is formed by the head-to-head overlap. Head-on collision. There will be what? Head-on collision. You can see here, head-on collision is there, right? But if the collision is like this, if it is like this, so it will be what? Pi overlap. It will be what? Pi overlap. This is what? Sigma overlapping, right? So it is formed by the head-to-head overlap of, that is what? Along with the internuclear axis, right? Getting my point? It is formed by the sideways overlap of atomic orbital. It is formed by the sideways overlap of atomic orbitals perpendicular to the internuclear axis, right? The overlap region is maximum. The overlap region is maximum, right? The overlap region is minimum, right? The orbitals is symmetrical to the rotation about the internuclear axis. The orbital is not symmetrical to the rotation about the internuclear axis. Getting my point? Now, last point is what? It leads to the formation of a strong bond. It leads to the formation of strong bond. It leads to the formation of weak bond. So pi bond is weaker bond. Pi bond is weaker bond. And sigma bond is what? It is stronger bond. Strong bond. So if I will be asking you which bond is stronger, so sigma will be stronger. Pi will be what? Weaker bond. Getting my point, everyone? Easy now? Is there any problem? Now, come to the next point. Condition for the combination of atomic orbitals, right? After all these, I will be giving my own trick to make you, make you comfortable in this molecular orbitals, right? So that you can easily write the molecular orbitals of any atom, any molecule, right? So the first condition is what? Molecular orbitals are formed by the combination of atomic orbitals that we have seen already, right? But all the types of orbitals combine with each other. The following are the main condition for the effective combination of atomic orbitals, right? The first one is what? The combining atomic orbitals must have same or nearly same energies that I have discussed, that 1s will combine with 1s only. 1s will not combine with 2s, right? 1s will be not combining with 2s. Why? There will be an energy gap between the 1s and 2s, so they will be not combining with each other, right? The second is what? The extent of overlapping between the atomic orbitals of two atoms should be large. The extent of overlapping between the atomic orbitals of the two atoms should be large. That is, greater the extent of overlap, the greater will be the electron density between the nuclei of the molecular orbitals. Next, see here, 2pz has combined with 2pz only, and 2px and 2px has been combined, right? Or you can say 2pz and 2py. Although they can, but there will be, there will be some possibility of combination only. So 2pz and 2pz can combine, and impossibility is what? 2pz and 2px. So there can be not possibility of joining 2pz and 2px, right? Getting my point? Or 2pz and 2py. 2pz and 2py. So the combining atomic orbitals must have the same symmetry. Here there will be symmetry, guys. Or proper orientation about the molecular axis. Getting my point? So if we take z-axis as the internuclear axis, so 2pz orbitals of one atom can combine with 2pz orbitals of the other atoms, but 2pz orbitals of one atom cannot combine with 2px or 2py. So 2pz cannot combine with what? 2px or 2py. Getting my point, everyone? So who will be telling me the condition that whether 1s will be combining with 2s or not? Atachaya, please write in the chat section, everyone. 1s will be combining with 2s or not? Or 1s will be combining with 2p or not? Or 1s will be combining with 2pz or not? Guys, write in the chat section. No. Only Anil Dev has written. Rest of you, what you are doing, guys? Yes, very good answer that you are giving, guys. Very good, very good. Okay, now see here. You can see here 2pz and 2pz is combining, right? You can see here 2px and 2px, or 2pz and 2py. So possibility of combination are what? 2px and 2pz and 2pg is combining. Impossibility is what? 2pz and 2px, or 2pg and 2py. There is an impossibility of combination. So 2s orbital of one atom can combine with 2pz. 2s orbital of one atom can combine with 2pz orbitals of another atom that you are seeing here, right? 2s, what do you say? It will be combining or not? What do you say, guys? But it cannot overlap 2px or 2py orbitals of another atoms. 2s orbitals of one atom A overlap with 2px orbitals of another atom B, that is plus overlap is there, and cancel, that is plus minus overlap will be there. As a result of no molecular orbitals is formed. In other words, such a combination is 2s with 2px or 2s with 2py is not possible. So 2s with 2px not possible, right? 2s with 2py is not possible. Getting my point, everyone? 2s and 2py will be not possible. 2s and 2py will be not possible. Why? 2s orbitals of one atom can combine with 2pz orbitals of another atom, but it cannot overlap with 2px or 2py orbitals of another atoms. When 2s orbitals of one atom A overlap with 2px orbitals of another atom B, so plus overlap will be there. So it will be cancelled by plus minus overlap. Getting my point, everyone? Now, see here. So 2pz will be combining with 2pz. So there will be a possible combination 2pz and 2pz. Impossibility will be what? 2pz and 2px, 2pz and 2py. So these are impossible combination. Here you can say 2px, 2pz and 2py, not combination. Getting my point? Easy? So we have seen that what will be the possibility and what will be the not possibilities. Here also you can see 2s and 2pz atomic orbitals and absence combination, right, of 2s and 2pz atomic orbitals. So you can see 2s and 2pz, and you can see 2s and 2pz. So this will be called as plus overlap, and this is called improper overlap or no net overlap. Now, so there are something that we have to discuss here is what? Energy level diagram of molecular orbitals. So that we will be going to see here, right? See, the energy of atomic, that is anti-bonding, or you can say that atomic orbitals combining to form molecular orbitals is what? The extent of overlapping between the atomic orbitals, the greater overlap will be there. So more energy bonding will be there. So more bonding orbitals is lower, and the anti-bonding orbitals is raised higher energy. That we have discussed. AO, anti-bonding orbital will be having higher energy, and bonding orbital and bonding molecular orbital will be having lesser energy level. That we have seen, right? So you can see here anti-bonding orbital raised is energy relative to AOS, atomic orbitals, right? So anti-bonding orbitals will be having higher energy in comparison to what? Atomic orbitals, right? Is it easy, guys? Now, bonding orbitals, that is sigma 2s, sigma 2pz, pi 2px, pi 2py, and anti-bonding, that is what? 5 2s, 2p, 2p, that we will be seeing here. in the next orbitals that we will be seeing here, right? Now, I'm going to make you write that how we can write the molecular orbitals, right? Or how we can make this diagram as well, right? Let's suppose first of all, here you can see here that is what? Lithium, Li2, right? Here is what? Lithium. Lithium is coming at what number? Lithium is coming at what number? Can anyone say me? Lithium is coming at what number? Hydrogen, helium, lithium, right, guys? So lithium is coming at what number? Hydrogen, then helium, then lithium. Everybody is comfortable here. Lithium is coming at what number? Third number. It is an element of what? Which period? Second period? Yes or no, guys? And it is a S block element. What do you say? It is a S block element, guys. So you can we write 2S? Can we write 2S for this lithium? Yes or no? Guys, please say me. For lithium, can we write 2S? So we have written what? 2S and 2S. Both sides. We have to write what? 2S and 2S, right? Getting my point? And one will be what? Sigma 2S and sigma star 2S. So this is what? This is anti-bonding molecular orbital. This is bonding molecular orbital. Easy, guys? Easy or not? First tell me that. Easy? See, if let's suppose if I have to draw for beryllium. So for beryllium, that what we will be doing? So see, 1s will be there. See, what will be there? 1s will be there. And 1 star will be there, right? Sigma star will be there. Again, same will be there. 2p will be there. 2p will be there, right? Getting my point? So what we can see? So these all molecules will be having the almost similar kind of molecular orbital. The main difference between the two types of sequence is that for molecule O2, F2, Ne2, the sigma 2pz and MO is lower in energy than pi 2pz. So now one thing that I will be going to tell you is what? Let's suppose we are having example of what? One example I am going to give you is what? Fluorine. First of all, tell me the general atomic orbitals, like this electronic configuration of this fluorine. Can we write 1s2, then 2s2, then 2p, 2p5, right? 2p5. Can we write? Sorry. Fluorine coming at what number? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, then fluorine, right? 2p5. Can we write 2p5? Yes or no, guys? Please say me. Can we write 2p5 or not? First tell me this. Guys, yes, 1s2, 2s2, 2p5, very good. So can you please say me that what we can write for the molecular orbital of F2? Another F that will be having same 1s2, 2s2, 2p6, 2p5, right? Think about this and what will be the molecular orbital, then please try to answer me. Think about this and give me the right answer. Think over this and try to give the answer. See guys, we have seen that if there will be what? Sigma and pi will be formed where? actually what we can write F2 molecular, if we have to write the configuration for this F2 molecular orbital, so how we can write 1s2, right? Then 1s star. Can we write 1s2 star? See here. First of all, what we'll be writing? Bonding, then anti-bonding, right? BMO. So 1s2 and 1s2, 2 times, 2s2, 2s2, 2 times, right? Then what we'll be writing? 2px, 2px, and what we'll be writing? What we will be writing? 2px, 2px, 2 times, 2py, 2py, 2 times, and 2pz, 2pz. Getting my point, everyone? Now, 1s and 1s star will be there, 2s and 2s star will be there, right? And now 2px, 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 2px star will be there, right? And 2py, 2py, there will be star will be there, right? Sorry, here there will be star will be there. 2py star will be there. And 2pz star will be there. Getting my point, everyone? So how we can write the molecular orbital of this F2? Is it easy now? Getting my point, everyone? How we can write the molecular orbital of F2? If there is any confusion, please ask. 1s2, 1s2, because 1s has combined with 1s to form the molecular orbital, that is 1s2, right? So 1s2, 1s2, 2s2, that is 1s2 and 1s2 star, 2s2, 2s2 star, 2px, 2px star, 2py and 2py star, and 2pz and 2pz star. Getting my point? Easy, guys. See here, for F2 molecule, see here, for O2, F2 and any two molecules, what will be the energy diagram, or you can say what will be the molecular orbital diagram? See here, 2s will be there, 2s will be there, right? So sigma 2s and sigma star 2s, right? Now 2px will be there and 2py will be there, 2px, 2py, 2px, 2py. So 2p star, sorry, pi star 2px and pi 2pxy is there. Getting my point? Easy or not? First tell me that. What do you say, guys? Let's suppose if I have to write for oxygen. Can you try for oxygen? Anybody who can try for oxygen? O2. If I will be going to ask you about the O2, then will you be able to write? Will you be able to write for O2? Will you be able to write for O2 molecule? Guys, please try for O2 molecule. Guys, I am helping you. If you are not able to do, then I am helping you here is what? See here. First of all, what we will be going to write? I hope everybody is knowing that 1s and 1s we will be writing, right? Then again 2s and 2s will be there, right? Then there will be what? 2px. There will be what? 2px and 2py will be there, right? 2px and 2py will be there, right everyone? And 2pz will be there. 2pz, right? Fine everyone. Then again 2px, 2py, 2px, 2py and 2pz will be there, right? Fine everyone. See, we have to see first where there will be single or sigma bond will be there. So see here. Here sigma will be there. What will be there? Sigma will be there. So we'll be writing what? Sigma 1s star, or you can say 1s sigma 1s star. You can say what? Sigma 1s star or sigma star 1s. We can say what? 1 sigma s. See here. Sigma 1s, sigma 1s star. Now for this 2s, sigma 2s and sigma 2s. Yes, very good answer is coming. Sigma 1s2, sigma 1s2, sigma 1s2, sigma star 1s2, sigma, yes, sigma 2s2, sigma 2 s2, sigma 2 star s2. Very good. Then pi, pi 2px, pi 2py, yes, and then pi 2pz and pi 2px. Just see, Anil Dev, I am writing here. Try first, listen from here what we are writing. Sigma 1s, sigma 1s star, sigma 2s and sigma 2s star, right? Sigma 2s star. Sigma star 2, sigma 1s, sigma star 1s, sigma 2s and sigma star 2s. Then after this, what do you think? See here, guys. There will be a formation of pi 2px and pi 2pz, right? Pi 2px and pi 2py. Pi 2px, I am writing here pi 2px, right? Pi 2px and equals to, that I am writing here equals to means what? Pi 2p, pi, sorry. Here there will be pi 2p, 2py will be there, right? Again, what will be there? Sigma 2pz, right? There will be what? Sigma 2pz, sigma 2pz, sigma 2pz. Then pi star, then again pi star, see here, pi star 2px, right? Pi star 2px equals to pi star 2py. Again, now last, sigma star 2pz. So what do you have written? Guys, there is not much difference, right? How to write this? You have to just calculate whether where there will be sigma, where there will be pi. If you have not understood even, we will be discussing more about this in the next in the next class.